Okay, so shall we go through some answers then? Let's go through some answers. Okay, so, yeah, by the way, so there was a question over there which kind of asked about the sort of structure of the question. In an exam situation, I will always try and make the question as clear as possible, okay? But if you're ever not sure, please feel free to stick your hand up, okay? So if you're like, I'm not quite sure about this, because I appreciate, for the majority of people in here, if not everybody in here, English is not the first language, okay? So if there's ever a language issue, or if there's ever like a construct, you're not quite sure what the question means, stick your hand up. And if it's something which I feel I can't tell you because it is actually it's being assessed, then I'll just turn around and say, I'm really sorry, I can't tell you. But if you're ever not sure, just be safe, just stick your hand up and I'll come around and ask you, okay? Or I can come around and tell you. Okay, so let's have a look at question 1 then, okay? So in how many ways can a group, so we've got 5 men, is it 5 men? So 5 women. And we have 4 men. And we want to know in how many ways can this group be ordered such that the men and the women must alternate. Now, what does alternate mean? Exactly, it's got to go man, woman, man, woman, man, woman, or woman, man, woman, man, woman, man. Okay? So, how many ways is this possible? How could we do it? Don't tell me the answer. Tell me how we could do it. Perfect. Are you happy? Because there's more men, because there's more women than men, it's got to start and end with a woman, right? So we've got to have, I'll do women in blue, okay? So woman, 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 and woman, okay? And then we just slot the 4 men in between the women. So we go men, man, man, and man, okay? So are you happy this situation here would be when men and women are alternating? Yeah? We all happy with that? Okay? And it has to be like that because there's more women than there are men. Okay? So it couldn't start off with a man because then we'd have 2 women together at the end. Is that okay? Right? So the question is then, well, how many different ways are there of ordering this group? What do we reckon? How could we do this? Yes? Absolutely right, okay? Because if you think about it, we know that women have to stand in this spot. That's the only way that can happen such that the men and the women will alternate. So the women have to stand in this spot, right? And the men have to also stand in this spot, or these spots, okay? So the men have to stand in those spots. So the question is then, if we know this position has to be a woman, this position, this position, this position, they all have to be women, okay? And these positions all have to be men, okay? Then you just basically say, well, look, the men can kind of shuffle around a lot. The women can shuffle around, but as long as they're standing in this position, it doesn't matter. So in other words, how many different ways are there of putting these 5 women in those 5 positions? 5 factorial. And the same question for the men. How many different ways are there of putting the men in these 4 positions? 4 factorial. Okay. How are we going to combine 5 factorial and 4 factorial? Multiplication, right? Because for every way that there is of arranging these 5 women, there's going to be that many ways of arranging those men. Make sense? Hence you should multiply them together. Is that okay? So what answer did we get for this? What number? There you go, 2,880. Does that make sense? Okay. Now, can I take your attention just for a second? So even if you've done question 1, can I have your attention just for a second? What if I changed it? What if I changed it so that we had the same number of men as we did women? So we had 4 men and 4 women. Now, if men and women must still alternate, how many different ways are there of getting this situation? So good, okay. So basically we got rid of a woman, okay, but we've still got 4 women, which means that there's going to be 4 factorial ways of arranging that. Okay, so 4 factorial ways multiplied by 4 factorial ways. So does that make sense? There's still sort of 4 factorial ways of arranging these 4 women. However, I've only considered the situation where we start with a woman and end with a man, okay? Are you happy that now, because there's the same number of men and women, it could also be the other way around? In other words, we could start with a man and end with a woman. Yeah? So in other words, for all of these ways, there's going to be twice as many when we have the reverse situation, where we start with a man and end with a woman, okay? So we're going to do this times 2. Yeah? Is that okay? So what's that? Is that 24 times 24, which is 480 plus whatever it is, okay? This is how you work it out. Does that make sense why we have to multiply by 2? Good. Okay. And in fact, question 2 is exactly what I've just solved there. Yeah, exactly what I've just solved. Okay, can we have a look at question 3, please? Question 3. So we have a committee of 5 people. So a committee, a group of 5 people, and that needs to be formed from 8 women and 7 men. So we've got 8 women, and we have 7 men. All right? Is it the other way around? Okay, that's fine. I guess it doesn't well, it does actually in this question. Okay, so we've got 8 men and 7 women, and we need to form a group, a committee of 5 people. How could we do that? So how many different ways are there of making a committee of 5 people from a group of 8 men and 7 women? However, we have a condition here. We need there to be more women than men on this committee. Okay, so we have 5 different positions to be filled, 2, 3, 4, 5, okay? And whatever happens, we must have more women than men. Is that okay? Mm-hmm. Right, okay. How could we do this?
So that means we can't have more than 2 men.
Exactly.
So that is,
Exactly that. So basically, we can't have more than 2 men. So if we have 3 men, then we've got more men than women. So we can't have that. So the conditions are, we can either have 0 men and how many women? All five members are women. Okay. Or we can have 1 man, in which case we're going to have 4 women. What else could we have? Good, 2 men and 3 women. And anything more than that, so we can't have 3 men and 2 women, because then we've got more men than women. Okay? So the condition is we must have more women than we have men. Okay? So really it's just a case of working out how many different ways there are of getting this, how many different ways there are of getting this, and how many different ways there are of getting this. Now just be careful of the wording of the question here. Okay? So we just want to choose a committee. We're not ordering them in any particular line, are we? So we're just looking at the number of ways of choosing this group, okay? In which case, we are going to be using this one. Does that make sense to everyone? Okay, it's not this one. It's not this one because we don't care about order in this case. So just remind me, what is the formula for NCR?
it's NPR over R.
Yeah, exactly, NPR over R factorial, or if you wanted to purely in terms of factorials.
N factorial over N minus R factorial.
Yep.
And then times R factorial.
Absolutely right. Now, by the way, I can't remember whether I showed you this yesterday. There is a button on your calculator which does this. You all happy with that? Okay, so it's literally, I think, above the times, and then there's one on the right as well, next to the divide. Okay. If you're using your phone, which I strongly recommend you don't, because you're not allowed to use your phone in exams, get used to using the calculator now. But there is a way of doing it on your phone as well. Okay, so how many ways are there of choosing 0 men and 5 women? Absolutely. Yeah, exactly. Or you can think of it as the men. So there's 8 men There's 8 men. In fact, let me do that in red as well to keep it consistent. Okay. So there's 8 men. How many men am I choosing? None. Okay. Now, if you stick that in your calculator, it is just 1 because there's one way of choosing 0 men from a group of 8. Okay. However, we need to think about choosing the women as well. So we start off with 7 women and we're choosing 5 of them. How are we going to combine these two things together? Multiplication. Because for every way there is of choosing the men, there's going to be that many ways of choosing the women. Yeah? So just because there's one way of choosing the men, there's going to be that many ways of choosing the women. Okay? If you like, if you're ever not sure, if it's an and situation, so if you want both things to happen, you should multiply them. Okay? If it's an or situation, which means you want this thing to happen or this thing to happen, but not both, then it's a plus situation. Okay? So if you're ever not sure. Here it's an and situation because we want this and this. Okay, we want both things to happen. Right? Okay, good. How many ways are there of doing this? So choosing 1 man and 4 women. Yeah, 8 choose. 8 choose 1. And how many ways are there of choosing 4 women? Perfect. And we're going to combine them together with a multiplication. Multiply, times. Okay? And then finally, you're happy, just very quickly, the last one's going to be 8 choose 2. That's how many ways there are of choosing 2 men from a group of 8. And 3 women will be 7 choose 3. And again, we're going to multiply them. So here's my question. Okay? At the moment, we're considering each thing separately. How are we going to combine them together to get our final answer? We're going to plus, because it's an or situation. Remember, we can't have all of these situations happening simultaneously. They can't all happen at the same time. So either this thing, or this thing, or this thing. So therefore, we're going to end up adding all of these things together. So we're going to add that, we're going to add that, and we're going to add that. Okay? Has anybody got a final answer for that?
So that is the shortest way to solve it by...
I think for me, it's the quickest way of solving it. But you notice with all of these questions, if you've done it slightly differently, but got the same answer, that's probably going to be okay. Okay? Because there's often more than one way of solving something. Okay? So did anybody get an answer for that? 1291? 1281. Okay, good.